There's something new from our sponsor, Text Control. For decades, TX Text Control's rendering was tied to Windows functionality. But now it's a new era. TX Text Control is platform independent. You can run your .NET applications on Windows or Linux, deploy with Docker containers, Kubernetes, or host directly in Azure App Services. Seamlessly integrate document editing, signing, collaboration, and PDF processing into your ASP.NET Core and Angular applications. Are you ready to see it in action? Check out the live demo at demos.textcontrol.com. That's demos.textcontrol.com. Hey friends, I'm Scott Hanselman, and this is another episode of Hansel Minutes, and today I'm chatting with Philip Kiley. He is the author of Inference Engineering, and he works at Baseten. You can check it out at baseten.co. How's it going, sir?
I'm doing great, Scott. It's an honor to be here.
Well, it's cool to hang out with you. So this book came out of nowhere, and you tweeted about it. I saw it. I saw the opening video, and then you were kind enough to send me a copy. Which I have read and dog-eared, and I've got a bunch of dog-eared pages here with questions that I want to ask you about. But I got to just shout out, like, there's just so much kind of like slop right now. There's so much AI slop. And then a book shows up that kind of like is the opposite in the sense of like, it smells good. It's got a really nice design. Like I was like, the first thing I thought was like, I hope they didn't AI generate the design. And then you actually shout out the author in the book who did the design custom. Like, it feels bespoke in a moment where everything's not bespoke. Was that a conscious decision to do something like that?
Absolutely. I mean, the thing is, Scott, I love writing books. I've done it before, but I've never done a good job like this. So it took me a few tries to get here. So I wrote Inference Engineering because number one, I love the topic, and number two, I love writing books. And if I was, just saying, I mean, you saw in the launch video, the very first line of the video was, hey, they made me take it out, but I was going to say, hey, Claude, write me a book. I just said, hey, write me a book called Inference Engineering, Make No Mistakes. It just doesn't work. You just can't do it. So,
well, that's the other thing.
Myself.
We gotta say right off the bat, when you're writing a book about AI, you're writing a book about the technologies that power AI. The first question that an interviewer has to ask is, did you AI slop the book and have the machine write the book for you? Or is this 4 years of actually writing hard?
So I tried my best to AI slop this because I came up with the idea for this book 6 months ago. And, if you go talk to a traditional publisher, which I did, they'll tell you, once you give me a manuscript, it'll take 12 to 18 months to get this thing out into the world. And I knew that I wanted to go from idea to finished hardcovers all over the world in 6 months. And so anything that I could do to make that faster, I wanted to do. So 100% I tried. I said, hey, can you come up with the outline? Can you write this chapter, write that chapter? But the quality was just completely unusable. There were a few places where I was able to use AI. So number one, by the way, Scott, have you done any long form writing? I assume you have it in your.
No, I've written a couple of books. Yeah. I've got and none of them used AI, and some of them are almost 1,000 pages long, and it's mostly it's code samples. Like, I mean, this is the thing. Like, ironically, we're talking about a book about AI. It doesn't feel like there's any AI. I read the book. I got the book marked up. None of my books are used AI because it doesn't hold a through line. It doesn't hold a topic long enough.
Exactly. So let me tell you how to use AI if you're writing a book, because for the most part, I didn't. If you look at, for example, chapter 4, section, the figure 4.1, this guy right here, it's a 6-line CUDA kernel.
Okay. Got it.
I asked for an example CUDA kernel. That saved me 30 minutes,
I see. So the code, so some of the code might be.
You can, it's small pieces like that save 30 minutes there, an hour there, that you can verify yourself and make sure they're good. It's, like I said, you've written before, how hard it is to look at the blank page. It's coming up with a few bad ideas so that I can throw those away and be inspired to create a good one. It's taking your outline or taking your sections and checking them for factual accuracy, checking them for completeness. But you can't just take the outputs and say, oh, well, every fact check it just gave me means all of this is wrong. No, that's just your to-do list to go do manually yourself. And then if you look in the back, like every time I write a book, I write custom software to make writing and laying out the book easier. So for example, like these QR codes and the layout of that. So I didn't, AI generate that because you can't. It's not going to be good. But I had Koso write me a script to do that. In Appendix A, it's alphabetized. I actually tried pasting the entirety of Appendix A into ChatGPT, and I said, hey, alphabetize this, and it got it wrong. And then I said, hey, Koso, write me a script that will alphabetize this, and it made 20 lines of Python, and it alphabetized it perfectly. So the main way that I used AI to write this book was not the actual words, was not the diagrams. The words are by me. The diagrams are by human artists and human designers. It's to write the code that makes everything else work faster in the writing, editing, and publishing process.
And I feel like, in a moment where there's just so much crap being generated, I think that is a good example of how you want to use AI. I always use the word toil. If it's tedious and it's toil, then AI will do it. Like you say, generating QR codes or writing scripts to alphabetize things. But if it's something like the cover, like I immediately looked at the cover and I was like, this is really cool. And I wanted to see the human name of the person that wrote the cover. You know what I mean? And this, it's like cover by Luke DeHaas, and shout out to Luke. And I don't know, it's just like people want both, and you want the hard parts that humans work on to feel hard. And I can feel that you were probably up late working on this book. Are you okay? Did you hurt yourself in the writing of the book?
There were a lot of very long writing days. The actual drafting piece was about a 6-week sprint where 4 days a week I would wake up at 5 a.m. and write until I fell asleep, and then the other 3 days I'd go to work and do my actual job. So yeah, and of course, shout out to Luke. He's the one of the brand designers that we have at Baseten, and he did a fantastic job on the cover and setting the design language for the interior. There's in chapter 1 this little diagram of some football players. That's my favorite art in the entire book. It was. I think this project was a great example of collaboration between multiple humans and between AI tools, because writing a book is toil. This, to overuse a metaphor, it's like running a marathon. No individual step is that hard. The hard part is taking all the steps back to back. Not every piece of toil can be automated. For example, that book you're holding in your hand is signed. Do you know how long it takes to sign 300 hardcovers? Because I just found out.
I did note your hands were a little shaky when you signed the book.
My handwriting's just that bad, Scott. That's just how it is.
The other thing that I think is worth noting, and I want to shout out like people who might buy the book or might think about getting into the digital download or a paper copy, is that this is a dense book. There's a lot of garbage out there that is just stuff you can learn online. What I appreciated about your effort was that I had to work pretty hard at this book. Like I had to, at points, I had to stop, look stuff up. There were a couple of times where I did ChatGPT voice mode and asked to understand stuff better. It is dense, and it seems surprising to me that a company that makes AI easier would write a book about the hard stuff. How did you decide to write a hard book rather than to like make a puff piece?
Well, for one thing, to me, this is kind of not the hard stuff. The hard stuff is what the model performance engineers are doing every day, and the infrastructure engineers. I'm just a friendly DevRel with an undergrad CS degree. No, I get what you mean. That's another reason that I couldn't use very much AI to write this. Is like the LLMs of today just don't know this material very well because it's so new. But My goal for this book, number one, was that anyone would be able to pick it up and read the first 20 pages
Mm-hmm.
and understand my vision for where the future of AI is going. And then number two, if they, make it through those 20 pages and they're really excited about the topic, that, any smart person with a decent technical background is going to be able to make it through the rest. And that meant making some trade-offs. I've definitely heard one of the, I think, most valid criticisms of this book is that it's a mile wide and an inch deep. It's very much a survey of all of these technologies. It doesn't necessarily teach you how to go hands-on and step-by-step do something. It's not one of your 1,000-page books with a ton of code samples and a ton of hands-on guidance. And the reason I made that decision is partially just because I wanted a book that I could write very quickly, and partially because the goal of this book is more to teach someone what questions to ask rather than give them all of the answers. So yeah, it is a dense book. It's a hard book, but we have all of the salespeople when they join Baseten, they read this and they get through it. So there's definitely, I think, a level of accessibility to the content that I prioritized.
Interesting. Yeah. I mean, I did. Survey seems light to say that it is a survey. I mean, it is an overview, surely, of everything that is going on right now at this moment in time. And I'm sure that in 2 years, you should probably start working on, or maybe a year, you should start working on the second edition.
Absolutely.
Right. Because that's the other irony of having a physical book with actual pages and actual dead trees means that, how much of this is out of date? Not a lot. It's actually pretty fresh. But it did give me a lot of questions to ask. And it's funny that you mentioned that because I'm looking here on my first question. I made it, let me see here, 41 pages in before I started dog-earing and looking stuff up. So you said if smart people can make it 20 pages in, that's a good sign. I made it 41,
Well, there
42 pages. So I feel somewhat validated about this. Did you feel uncomfortable that you don't have a PhD in machine learning and deep learning? Did you say should I be the one that writes the book? How did you deal with that? Because I always feel like an imposter when I'm writing technical books.
I am blessed with a complete absence of imposter syndrome.
Oh wow, you were the first. That's amazing. Tell us your ways.
Perhaps some people in my life would tell me that a little bit of it might be good for me, but I think that there's a very academic take on AI that starts, in the early days and defines what a perceptron is and teaches you what a convolutional neural network is and all that kind of stuff. And I entered the AI industry in 2022, January of 2022, about 10 months before ChatGPT became a huge thing. And I didn't know any of that stuff. And that hasn't stopped me from doing my job today. I'm sure all of that stuff is very valuable, and I've enjoyed learning, bits and pieces of it along the way. But I believe, and this is part of the thesis of this project, that you can make a valuable contribution to the AI industry without a incredibly rigorous academic background, and that the technologies of today are so new and moving so fast that in some ways it's an advantage to not know what you're doing, because at least this way you don't have any bad habits to break.
Yeah, that's interesting. It's funny that you mentioned that because I've talked about what it feels like to be towards the other side of your career, at the end of your career. So one could argue that you're in the opening 10 years of your career and I'm in the latter 10 of mine. So then should we, we shouldn't gatekeep this stuff just because someone's old or someone's young or someone came in at the beginning of the hockey stick growth within inference, or someone started it at MIT or worked on the project in the 70s with so-and-so. So you're right. Young people with fresh ideas and fresh perspectives are what's going to actually do the work and make this thing useful. So one of the questions I wanted to ask about usefulness is, this talks about hardware, it talks about software, it talks about, like I said, an overview of all the different GPUs, how they work, performance profiling. But underneath it is a reminder that none of this is anything unless it actually does interesting and helpful work. Do you think about the what can be done with AI? Because we opened this podcast by saying it can't write a book. And I don't know if I want it to write a book. Like, I'm not interested in AI slop. I'm interested in AI, to our point, doing toil. So I'm curious about your personal opinion. Like, here we are with a book on AI inference, but the book couldn't today be written by an AI and be any good.
I think very little about vertical AI applications, actually. I
Really?
mostly because I spend so much of my day taking other people's vertical applications and
Hmm.
helping them figure out how to make it twice as fast and half as expensive. So I will say that, as a software engineer, off and on throughout my career, obviously the past couple months have been very exciting, and I feel like I have regained the ability to ship production code, because there's some trade-offs in coming into more of the content space, coming into taking 6 months and writing a book, in that your other skills can atrophy a little bit. So I find that I've been able to augment the sort of missing capabilities and ship the stuff that I'm really excited about, no matter where it is. Another thing is, video editing. I do a lot of video editing with Descript
Mm-hmm.
because I'm not a fast or skilled editor. If anyone had a chance to watch my college YouTube videos before I took those down a few years ago, they would certainly know that I'm no Casey Neistat.
Mm.
That's kind of the vision that I have for this space. It doesn't particularly matter what my vision is. It matters the vision of the people who are actually building the tools, not just making them faster. But my vision and my hope is that I'm going to be able to keep doing the things that I really love and outsource the pieces that I am not so good at, and create things that otherwise I just would have left on my to-do list.
That's a healthy attitude. I appreciate that. Like, you're staying in your lane, and you might dip your toes in another lane, but you know what you're good at, and you stay away from the stuff that you're not. So base 10 is about speed, right? Like, it's about making it better. And a lot of people myself, I'm concerned about, you know, wasting energy on AI. And you spend a lot of time in the book talking about performance. There's a ton, like, you start right off the bat about, like, they're already making it faster. You talk about the difference between time to first token versus throughput. The whole thing is about throughput. Honestly, if there was like uh, a through line through the book, it's like it's getting faster and it's going to get faster. How much faster do you think it can actually get? And is that going to be good in the sense of we'll waste less energy and it won't cost this many teaspoons of water to ask a question of a model?
So with performance, there's a couple ways to think about it. It's a multivariable optimization problem. But
Mm-hmm.
let's think just about three variables right now: speed, cost, cost and throughput are the same thing, and quality, the correctness of the output. So quality is fixed at the model level. So let's take the model as fixed for a second. So now we only have to think about two variables, which are speed and cost or throughput. And you can plot an efficient frontier where on one axis you have speed, one axis you have cost. You can be maximally fast at a very high cost. You can be maximally cheap, but you're not going to be very fast. And then there's an efficient frontier curve between those two. Some model performance work is just figuring out where that efficient frontier is and helping you adjust the knobs and dials within your inference engine and whatnot to get to the place that you want to go on that frontier. And then some performance work, more on the research side, is pushing that frontier out. And when you do that, when you create some kind of optimization that unlocks better performance, you can choose to move along the new frontier to either more speed at the same cost, or less cost at the same speed. So then you add back the quality axis. Suddenly your efficient frontier becomes a sphere instead of a curved line. And as you either fine tune a small open source model to replace a large model, get a new performance frontier, find a spot along that, you ultimately, like, as this research continues, you're able to push out and out your options around speed, cost, and quality. Again, kind of staying in my lane, like, what I'm focused on is making the sphere as big as possible, making it so that you have as much sort of performance as a vague and term to spend in these trade-offs. Where does that actually go? We definitely see with inference getting cheaper and inference getting faster that the same amount of traffic that you maybe had 6 months ago, you can now serve with a fraction of the hardware, or you can now serve for a fraction of the cost. You can now serve at a much better speed. But that is overshadowed by increases in demand. It's funny because a lot of the time we spend as a company is like trying to figure out how to get our customers to pay us less. Because if you can make your inference X times faster or X times cheaper, you need fewer GPUs, there's less consumption. But that always gets rewarded with more workloads and more demand from the market.
Right.
So at the sort of, there's perhaps three layers to the answer to the question. There's the micro layer of, on a workload by workload basis, yes, we're making it faster and cheaper and less consumptive. And then at a macro level above that, maybe that increases demand. But at the macro level above that, well, the demand was there anyway. So eventually we're going to just be able to fulfill it, and we better do so in the most efficient way possible.
Yeah. There's the old computer engineering joke, which is you can have it good, fast, or cheap, pick two. And there's always this idea that you can never have all three. But I think in the world of inference, in the world of AI, people expect, and the market expects, all three. And what I'm hearing you say is that you can optimize for two, and then you'll bring that third one back up. So like there will be good and fast, and then maybe it won't be cheap, but then it will become cheap. And we are consistently seeing people using like hard math and hard computer science to make it good, fast, and cheap all at the same time.
And then the fourth one, and this is one that a lot of people don't really talk about, but is actually very critical, is reliable. Because you have obviously all of the questions around the model reliability and the prompting and the JSON mode output, structured output, function calling, whatever you're doing at the model level to make it reliable. Setting that aside, there's the infrastructure reliability piece. How many nines of uptime are you getting from GPUs, which notoriously are not a very high nine piece of hardware? You've got that. You've got the cloud provider reliability piece. You have the reliability of the inference optimizations that you're making. When you quantize, are you keeping quality intact? Is some novel speculation algorithm that you're introducing going to run into some niche bug and cause out-of-memory errors every so often? There's all kinds of applied research in the AI space that in other industries might take years or decades to make it into production. And here we go from, paper to running on the GPU, serving massive production traffic in weeks in many cases. So there's a lot of work around like taking sort of research grade ideas and research grade software and hardening it to the point that you can serve a customer who has a 4 or 5 9 of uptime SLA because they're doing something critical, like an AI tool for doctors or some kind of financial tool.
I want to shift gears a little bit because I'm thinking about, like you're saying, getting into production, and I'm seeing people call themselves prompt engineers a lot, and that kind of bugs me. I don't really like that term because there's a feeling that you can really control the black box by just poking at it with prose, and I'm wondering if you can maybe juxtapose or explain the difference between prompt engineering and inference engineering.
Absolutely. We are building the playground that the prompt engineers hang out in. There is some overlap. So, for example, at the inference engine level, you can guarantee certain structured output pieces. If you look at back in 2023, 2024, there was a big movement around JSON output from models and how do you get it to return an object. And there was, for a long time, a very prompt first view of this problem, which is like, you must return JSON and only JSON or my grandma's going to die. And that's just not something that you want to bet your production workload on. So now through the inference piece, we have the ability to guarantee a structured output. And the way that works is you define a schema, you send that in, and along with your prompt. And what the inference engine does is it creates a state machine and it uses something called logic biasing. So to dive into the concepts of inference a little bit, and a large language model has something called a vocabulary, which is every single one of the 100,000 tokens it could possibly produce. And when it does a forward pass for inference to create that next token, what it actually does is it creates a vector of 100,000 probabilities of which token might be generated. With logic biasing, you do something called masking that vector. So basically, you take every token that would not be valid syntax according to the state machine for your JSON schema, and you just set the probability of that to 0 or negative infinity, depending on how you're doing it. And then you still let the model do its generative thing, but you structurally guarantee that no invalid tokens are going to be generated. And prompting, of course, in this case still matters because the contents of the JSON object that you're creating are not guaranteed by the schema. So it being, accurate and quality data is still up to you in the prompting side. But the actual structure of the output is now guaranteed by the inference engine. So that's an example of, that's been the standard in production now for 18 to 24 months. But that's an example of where the inference side can come in and help the prompt side. But there's also places the prompt side can come help the inference side. So one of the biggest optimizations we do is KV cache reuse, where we're able to take the first few tokens of a prompt and reuse them between different requests as long as they match perfectly. So, for example, if you put your system prompt before your conversation, or if you put all your shared context up front, and then you change whatever's new about this specific request at the back of your prompt, your actual inference speed is going to be many times higher than if you put the novel stuff at the front of the prompt. So there's a lot of interaction actually between the prompt and the inference layer. Yeah. So they have to work together to make a system completely optimized.
I do think, though, that people over pivot, especially when they're first starting building an actual production system. They over pivot on their prompts. You see people on Twitter this 20-line MD file is going to change the way your whole system works. And it's like putting "don't do this" in all caps. There's no guarantee that it's not going to do that. Like you just said, make sure that you return JSON all caps. And it's yeah, but I said it in all caps and it still did it the other way. It is an ambiguity loop, and you're going to get ambiguous results unless there's something probabilistic and actual deterministic code that says this will only return JSON, or you need a firewall, I guess is what I'm saying. Yeah. And the way you're describing that mask it is a kind of a firewall. The machine's going to do what it's going to do, but we're not going to let bad results come out no matter what the prompt says.
Exactly. It's the mix of using AI for what it's good at and using straight up Python for what it's good at. So for example, when I was proofreading the book, you would think models would be great at proofreading. They're not. And one of the things that makes them not good at it, though, is if you dump 47,000 words into a single chat window, it's not going to be able to go in and catch every error. But if you write a script that sends the book to the model a page at a time, you're going to get much better results. So there's that aspect of it as well, as just knowing how these systems work under the hood makes you better at using them and helps you build systems that get better results.
See, then you would love the analogy that I know my listeners are sick of me using, which is the learn how to drive stick shift. If you learn how to drive stick shift, you have a different relationship with the vehicle. And I think a book like this is very much here's how the internal combustion engine works. And now that you know how to drive stick, go back off and think about how to move people around and think about the concepts around transportation, but always have the engine and what's happening in inference engineering underneath, so that you know what you can actually affect in the larger system.
Scott, that would be a fantastic metaphor, but I don't know how to drive. So,
oh my God, you're killing me.
Waymo guy.
See, this is the thing. I love this. We're ending the show where you're a Waymo person, but see, the system requires you to know how to drive the Waymo. So the Waymo breaks down, you're going to get eaten by the zombies first, is what I'm hearing. And I'm going to jump in. I'm going to hotwire the car, throw it into first gear, and zip away.
That's true. But at least I understand when the Waymo makes a mistake, why it's making it. So it just, gives me a little bit more empathy for the machine.
This is why when the zombies come, we team up. It's a Philip and Hanselman partnership where I will drive stick, you will handle the Waymo. Between us, the zombies will not get us.
You're welcome on my zombie apocalypse squad anytime. I do also bring about 20 years of martial arts experience. That's my primary zombie apocalypse contribution.
Very good. Well, I have a black belt in Taekwondo, but I'm more of a slap fighter. So I will be standing behind you when the zombies come. Well, this has been fun, and congratulations. It's hard to write a book. It's hard to ship a book, and it's hard to get it into people's hands. And you all and the folks that you work with at Baseten, like you pulled it off.
Thank you.
And
it is very hard to get it in people's hands. I have made best friends with the members of my local FedEx office.
Yeah, it is hard work.
4096 in San Francisco. Highly recommended. Shout out the crew there.
There's definitely a lot to learn. And also, just another thing I just wanted to say, like, I really thought that the QR codes at the end were just such a nice touch. I just hate the idea that I'm going to get a book and have to type the URLs in. And there's a huge appendix. Like, honestly, there's probably 50 pages of just good, like there's a glossary. It's just a thoughtful thing. So yeah, maybe the haters say that it's not deep. I found it to be just the right amount of deepness as a great survey for inference engineering. And I enjoyed it very much. And I appreciate you sending me a copy.
Well, fantastic, Scott. That means a lot coming from you.
I'm glad. So you can go ahead and check them out at baseten.co. That's baseten.co. Right at the top there, you can get your copy, get your digital copy, and then there's a wait list now for the paper copies because they're hard to get and they're super popular.
They are. And Amazon, despite the fact that I have thousands and thousands of people now signed up to get paper copies, doesn't seem to want to list it. So we're going to have to find a way around that.
Well, hopefully you'll figure it out soon. Thank you so much, Philip Kiley, for chatting with me today.
Thank you, Scott. Have a good one.
This has been another episode of Hansel Minutes, and we'll see you again next week.